Good morning, dear students. In the previous lecture, we discussed about classification of air pollutants as well as various effects of air pollution. Today, in this lecture, we'll discuss about the control of air pollution. I'll try to discuss about different types of equipments which are currently in practice for controlling gaseous as well as solid particles which are considered as air pollutants. So let's start our today's lecture. First of all, I would like to tell you about the control of air pollution. And in this category, we'll discuss that how the dust particles can be removed from industrial polluted gases. We know that dust particles are also known as particulate matter or suspended particulate matter. These dust particles are so small in size that they cannot settle down on the ground, so they remain suspended in the air. And based on their nature, these dust particles could cause various harmful effects on the human beings or the living organisms if they enter inside the living organisms' bodies. So let us see that how the particulate matter can be controlled using different equipments in the industries. The first equipment that is that was devised to separate dust particles from the industrial flue gas is called as gravity settling chamber. The gravity settling chamber is very simple in design, and this is very old equipment which was devised or developed long back for separation of dust particles from the industrial air. This picture shows the structure of a gravity settling chamber. You can see that it is cylindrical in shape, tapering at the both ends. The one end of this chamber is fixed as inlet point from where the polluted air is allowed to enter inside the chamber. The rear end of this chamber is called as outlet point from where the clean gas will come after separation of solids inside this chamber. In the bottom, you can see two structures which are named as dust hoppers. These are the conical structures which are made at the uh, bottom of this chamber, and these are designed and made in order to receive the dust particles which are separated from the polluted air. So when the polluted air enters inside this gravity settling chamber, the gravity settling chambers remove the solid particles by settling them at the hoppers by force of gravity. So what we do in this case, that a known volume of air is entered inside the chamber, and both inlets and outlet points are closed. The polluted air is allowed to stay inside this chamber for some time, and during this period the large size particles can settle down by force of gravity, and they may fall in the openings of the dust hoppers. And when dust particles are settled down, the clean air is taken out by opening the outlet point. And when the entire volume of gas is taken out of this chamber, the valve of the hoppers can be opened to remove dust particles from the gravity settling chamber. But these chambers can only remove solid particles which are greater than 50 micron meter in size. So gravity settling chambers can only remove the dust particles which are more than 50 micron meter in diameter. So If the particle size is less than 50 micron meter, then gravity settling chambers will not work in that case. So in such cases, we look for the another more sophisticated and efficient equipments for separation of small size or fine size dust particles. The velocity of the polluted gas should not exceed 3 meter per second whenever the treatment is carried out by gravity settling chambers. Because if the velocity will be high, then the polluted air will take longer time to separate dust particles inside the chamber. So the velocity should be less than 3 meter per second. The velocity of gas should be more or less uniform, because if there will be difference in the velocity of gas, then that will create turbulence inside the gravity settling chamber, and in such cases all the settled particles will again reach to the chamber area, and the efficiency of this gravity settling chamber will drop down. So two three things have to be kept in mind while treating any polluted gas for separation of solid particles using gravity settling chamber. First, the gas has to enter inside the chamber at a very low velocity, less than 3 meter per second. Second, the velocity of gas should be more or less uniform. It should not fluctuate. The next equipment that is used for separation of solid particles from the gas, industrial gas, is called as cyclone separators. These cyclone separators are more advanced compared to the gravity settling chambers. Let us see first of all the structure of a cyclone separator. A cyclone separator is a vertically elongated chamber made up of metal, and from top to down, the diameter of the cyclone separator decreases. So the bottom point of the cyclone separator tapers at the end, forming a hopper-like structure where dust particles are collected. So in cyclone separators, the basic principle of separation of dust particle is principle of inertia separation. The dust particles are allowed to enter from the inlet point inside this cyclone separator, and this gas is entered in the chamber tangentially. So when the gas is entered in the chamber with an angle, the as the gas changes its direction after striking the inner wall of this chamber, the inertia of dust particles causes them to continue in original direction, and in this way they get separated from the gas. When gas enters inside the chamber and changes its direction, the gas gets diverted, whereas the dust particle could not get diverted along with the gas because of the law of inertia. And in this way, they get separated from the gas while uh, striking at the inner surface of this cyclone separator. The walls of the chamber tapers towards the bottom, which we can see through this picture also. So when these dust particles will strike at the inner wall of this cyclone separator, then these dust particles slip down and move towards the bottom part of the cyclone separator, where they get collected in the hopper. The clean air moves out through the top of this chamber. In this diagram also it can be seen the outlet of this chamber is on the top, where we have written clean air. The cyclone separators can only remove dust particles of size more than 10 micron meter. In case of gravity settling chamber, we saw that those chambers were only able to remove particles of 50 micron meter size or more, whereas in case of cyclone separator, the size has been reduced to 10 micron meter or more. So they are more advanced compared to the gravity settling chamber. So if we want to remove the dust particles which have size less than 10 micrometer, then in that case cyclone separators will not work. So we'll have to look for another better equipment which can remove the particles size less than 10 micrometer also. So cyclone separators can be very easily seen in the different kind of industries because these equipments occupy very less space as they are vertically elongated. The polluted air is allowed to enter with a good velocity. So in less amount of time we can purify large volumes of gases, as well as the efficiency of cyclone separators are good, and the particle size is also uh, which can be removed is more than 10 micrometer. So in case of efficiency, in case of space requirement, and in case of its maintenance, cyclone separators are a good choice of the different industrialists. So next equipment is wet scrubbers. First of all, we'll see the diagram. So this is how a wet scrubber looks. It is more or less similar to the cyclone separators in shape, but the difference is that the polluted or dirty air is allowed to enter from bottom point or bottom part of the equipment. The cyclone separators are fitted with the water spraying system. These are fitted internally with the pipes fitted with the sprinklers or the sprayers from where the water can be sprayed over the polluted gas. So when the dirty gas enters inside the chamber uh, from the bottom point, it moves vertically upward. And when this air moves vertically upward, it comes in contact with the sprayed water. When it is moving from bottom to the top, the water is sprayed over these gases. So what happens at that time, that water brings dust particles along with it to the bottom point, which is known as hopper, and all the water mixed dust particles are collected at the tapered hopper, and the clean air can move out of the chamber through the upper part where an outlet point is given. The problem related with the wet scrubbers is that the after the removal of the polluted after the removal of dust particles, we have a waste material, that is dust mix water, and which is actually acidic in nature, because whenever the water will be sprayed over the gases, and it uh, collects dust particles, but it also reacts with the different gases which are present in that flue gas. It can react with sulfur dioxide or carbon dioxide or oxides of nitrogen in the gases, and uh, in this reaction acids may be formed. If it reacts with carbon dioxide, then carbonic acid will be formed. If it reacts with sulfur dioxide, then sulfuric acid, and in case of oxides of nitrogen, nitric acid is formed. So that dust mix water which is collected at the hopper or the bottom point is actually acidic in nature, and managing or treating this acidic nature wastewater is again a problem. So otherwise these wet scrubbers can perform very well in separation of dust particles from the industrial polluted gas. The next equipment which is used for separation of particulate matter from flue gas is known as fabric filters, and these are also named as baghouse filters. So in fabric and baghouse filters, again these are cylindrical in shape, tapering at the bottom, and inside the chamber of these fabric bags, the fabric cylinders, the cylinders made up of fabrics, special fabrics are installed. You can see through this diagram also. So Whenever polluted air is allowed to enter from the bottom point, then this polluted air contains dust particles of different sizes. So by knowing the size of these dust particles, we can fix that which quality of or which pore size of fabric filters should be used. For example, if I am intending to separate the dust particles which are 50 micron meter in size through this fabric filters, then my filter pore size should be less than 50 micron meter. In that case, because the pore size of dust particle is more than the pore size of fabric filter, so whenever this particulate matter mix air will come in contact with the fabric surface, the dust particles will get stopped on the fabric surface because the pore size of fabric filters are less than the size of dust particles, and gas can move very easily through the fabric filters. So in this case, they act as a barrier to remove the dust particles from the polluted air. So in the second diagram, we can very easily see that how the dust particles are retained by this fabric material. So we have woven filters which are actually fabric filters, and whenever the dirty gas strikes these fabric filters, then the dust particles will remain adhered to the surface of these fabric filters, and air can move out of these fabric filters, which is actually the clean air. And in this way, dust can be removed. Dust will remain inside the chamber and clean air can be taken out. So now the question arises that what happens when the filter gets choked by exposing to the polluted air. So when these filters will get choked, they are treated for removal of these adhered dust particles. So in that case, the compressed air is pumped inside these filters so that the dust particles which are adhered on the surface of these fabric filters will forcibly uh, get detached from the fabric surface and reach to the hopper point or the tapering bottom, and from there it can be removed very easily by opening the valve of these hoppers. But whenever we use these fabric or baghouse filters, these filters are associated with certain limitations. We'll see that what are those conditions under which we cannot use this fabric or baghouse filters. So limitations of a fabric or baghouse filters are as follows. First, if the temperature of your flue gas or the polluted gas is high, then in that case it is not advised to use these fabric filters because the high temperature of the gas can lead to the damage of fabric filters and can cause accident by catching fire. Your fabric can catch fire in that case, and it can damage your equipment, as well as it can also cause accident in your industrial premises. So high temperature gas should be first of all cooled down uh, to bring the temperature to the normal. Then only that polluted air should be treated uh, through these fabric baghouse filters. If the temperature of gas is high, in that case, wet scrubbers can perform well, because when you spray water, cold water over uh, the polluted air which has high temperature, then in that case it will not only remove the dust particles from the flue gas but also lower the temperature of air. So by one equipment you can perform two actions. It can separate your dust particles from the air, as well as it can also bring down the temperature of your gas. The second limitation of a fabric or a baghouse filter is that if the polluted air contains acid fumes, in many industries, if acids are used in some uh, process, production process, then the fumes of the acid may come out along with the polluted gas. In that case, because acids can cause damage to the filter material, then the efficiency of your baghouse filters can drop down. Because these baghouse filters are very costly, then in that case you will have to remove your baghouse filters very frequently if it is if these filters are exposed to the acid fumes. So gases having acid fumes are also not advised to be treated using these baghouse filters. The third limitation is that if your air has high humidity, if your air has water vapors or high humidity, then in that case, whenever this moist air will come in contact with the fabric surface, the dust particles will get tightly attached or adhered to the filter surface in the form of a dusty cake layer. So if that thick cake layer will be formed over the surface of your fabric, then there will be clogging of your filter material and no air will pass through your fabric filter. In that case, your filter will get choked and the efficient equipment will stop functioning. So if your air has these conditions, then it is not good to treat such kind of air using baghouse filters. Otherwise, the efficiency of baghouse filters are very good. It's more than 90% removal. This is a picture of a fabric or baghouse filter fitted in an industry. You can see that how these baghouse filters look like. You can see the tapering end from where the dust particles are removed. Now the next equipment which is considered as most advanced equipment in removal of particulate matter from the polluted air is called electrostatic precipitator. In short, we call this equipment as ESP. In this diagram, you can see that an ESP is always installed before the chimney, before the stack. So whenever the air is polluted air is generated in any industrial plant, then that polluted air, instead of taking directly to the chimney, it should be taken to the electrostatic precipitator where the dust particles are removed and the clean air then can be connected to the stack or the chimney from where it can go to the atmosphere. So how these electrostatic precipitators work, let's see. An ESP uses electricity of high voltage difference to separate dust particles from the polluted gas. In case of electrostatic precipitators, we use electricity of very high voltage difference, that is more than 50,000 volt difference, to separate dust particles from the polluted gas. The ESP is made up of a metallic chamber. The chamber is supplied with positive charge on dust collecting electrodes and negative charge on the discharge electrodes. We'll see now in the next slide through a diagram also. This metallic chamber has two electrodes. First is the positive charge electrode, and that is known as dust collecting electrode. Another is negatively charged electrode. So, and the difference of voltage between these two electrodes is very high. So, when the dust particles come in contact with the negatively charged discharge electrode, which is inside this chamber. So, when you will enter your polluted air inside the ESP, the polluted air will come in contact with the discharge electrode, which is highly negatively charged. Then that discharge electrode will transfer that negative charge to the dust particles also, and in this process those dust particles will also get negatively charged. Now when these negatively charged dust particles will move in the ESP chamber, the chamber is surrounded from both sides by the positively charged collecting electrodes. So we know that opposite charges always attract each other, and by this principle, the negatively charged dust particles will get attracted towards the positively charged collecting electrode, and these dust particles will get sticked to the surface of these positively charged collecting electrodes, and in this way all the dust particles will get attached to the collecting electrode surface, and the clean air will move out of the ESP chamber. The efficiency of an ESP or electrostatic precipitator is more than 99.99%. Even the very fine size particle, dust particle, can also be easily removed using ESP, because it can easily get charged by coming in contact with the negative charge electrode, and it can be adhered to the positively charged collecting electrode. So this is the diagram which I have prepared to explain it more clearly. This is a chamber of an ESP which have two outlets. The bottom outlet is known as inlet point, from where the dust particles latent gas will be allowed to enter. You can see that in the bottom part I have placed a yellow colored line which I have named as negatively charged metal grid. So when these white colored dust particles come in contact with the negatively charged metal grid, those dust particles will also get negatively charged. Now when these negatively charged dust particles will move, so at the point A, I have written that dust particles gets negatively charged after coming in contact with negatively charged metal grid. So when these negatively charged particles will move ahead in this chamber, then they will come in contact with the positively charged collecting plates, which you can see I have shown it through uh, white color on the both sides of the chamber. Uh, At the point B, I have written dust attached to the collecting plates. So these positively charged collecting plates will attract the negatively charged dust particles, and all the dust particles will get attached to the surface of positively charged collecting plates. In this figure, the yellow colored dust particles are attached because they are negatively charged and the charge on the plates are positive. They will get attached to the positively charged collecting plates or electrodes, and the clean air will go out of the ESP through the outlet end. So this is how an ESP works. Although we have many benefits of using ESPs, the efficiency is very high, especially if you want to separate dust particles from the industries which are very highly polluted in terms of dust particle concentration, such as cement industry. The concentration of dust particles in a cement industry is very high, and in such cases the baghouse filters or cyclone separators will not work because the concentration is so high that it cannot be handled using wet scrubbers or gravity settling chambers. In that case we need a equipment which is very efficient and very quick in separating dust particles from the polluted air. So in that case, ESP can be the only choice, because ESP can remove even the very fine size of dust particles in a very short time. So this is how the ESP works uh, during the separation of dust particles from the polluted air from industries. So this is a picture of an ESP which is installed in an industry. You can see that it is tapering at the end when the dust particles will get attached to the positive electrodes and clean air will move out. Then through the mechanical hammers we can remove these dust particles from the plate surface and settle these particles at the hopper, and from hopper by opening the valve we can take these particles out. Once these dust particles are taken out, they can be used to fill the earthen uh, surface where we need a filling using soil. So instead of soil it can be filled using the dust particles. So this is how the solid particles are removed from the polluted air, especially in the industries. In the next lecture, we'll talk about that how the gaseous pollutants are controlled or managed using different techniques. So that was all about today. See you in the next lecture. Thank you.